Hey, this is OXDF, and today we're doing day 8 of the 2016 Advent of Code, which is the 2023 revival of code. It's called two-factor authentication, and I'm going to level with you right at the beginning. I recorded a 30-minute video of me solving this and realized I did not hit record. So I just RMRF'd that entire directory, and we're going to do it again. Hopefully I'll be less error prone this time, so let's take a look. The basics of this challenge is I'm going to get a bunch of lines that look like these formats right here. And so, oh, I guess I should say I start with a display. And so in the real example, it's 50 pixels wide by 6 pixels tall, and they all start off. And then in this example, I'm going to have, it looks like 7 pixels wide by 3 pixels tall. And so you can get a Rect command, which means at the top left corner, do 3 by 2, and turn those all on. If they're already on, they just stay on. Then there's this rotate column, which, so if we take x equals 1, so we 0 number, so this is the first column. You can see here it was on, off. Now they rotated down, so it's on, off, on. We can rotate a row, so this would be like the top row here. You see these two kind of got picked up and shifted over 4. And then we can rotate a column again here. In this case, you can see we rotate off the bottom and back around the top. So it's kind of continuous in that way. For part 1, all I need to do is figure out how many pixels are lit. You'd think we might be able to look at just the Rect, but you know, they rotate on top of each other, and so it's possible that that would overcount. So don't look at part 2 yet, because we're going to pretend we haven't gotten there. And let's go ahead and jump into VS Code. I'm going to rerun my genday script here. This script is going to pull the puzzle input for me, as well as create these stubs for me. I'm also going to go here and grab, let's see, we want these 4 lines here. We can start to figure out what our tests are going to look like. All right, if we come here, I am going to use this fixture here this time, so we can grab this and control slash. We're going to read an example1.txt, so let's go ahead and create that file. Example1.txt, and we just need these lines here that have the actual commands. So we'll do that, and that. Beautiful. Okay. So what that's going to do now is because I've got this set up here as a fixture, what that means is I can now pass example1 as an argument into any of my other test functions, and I will get access to the result of this function. So in this case, it's going to read example1, read text, strip, and give me the puzzle input. Cool. So we're going to do, in the past, for these simpler problems, I've just sort of had a test part 1 and test part 2. I'm actually going to do some more tests this time. So we're going to start with a test parse function, and that will take example 1. So we're going to get the example data. Now I'm going to design this, I'm going to organize this around a class called I'm going to call it a screen class, and that screen class is going to take example input, and it's going to parse it into a set of instructions, and then I can run those instructions, and I'll keep track of them in a screen as well, all within the same class. So I'm going to say screen is equal to, let's see, AOC, because that's what I've imported day 8 as AOC, dot screen. And I'm going to pass in example 1. And then I should be able to say things like assert screen dot instructions sub 0 is equal to, and we better go grab this from, let's see, we will do it here. We will open up example 1 to the side. I think my head's right over here, so I think you still can see this. And so example 1, I'm going to get that back, and that's going to be a tuple that says like Rect 3, 2. I need 2 equal signs there. And so I can do the same thing here. Let's grab this like this, and we have 4 instructions, so 1, 2, 3. We'll change this to 1, 2, 3. This one will be, I'm just going to call it column to tell myself that we need that there. This one is row, and here we have 1, 1. Here we have 0, 4. Basically what I'm saying is I want to take this input and parse it so I just have the key pieces I need. So this will be 1, 1 again. And I think that's all I need here to start this. We can come down here and do PyTest. And we are failing because day 8 has no attribute screen. That's expected. Let's go ahead and open this up, and we will start working on it. We can do, let's see, one more. It's class screen. And then we're going to need a def init. And it's going to take a self, and it's going to take in puzzle input. And now, in fact, we can even come here and rerun PyTest, and now we will get a screen, but screen has no attribute ints. Cool. So now we need to figure out like how we got to process this. So we'll come here and we'll say self.insts equals an empty list, and then we can do for line in puzzle input dot. We got to strip this just to be sure. Well, I think we stripped it somewhere else. We can do split lines. So for each line, what are we going to do? First thing we're doing is going to break that line into tokens. Oops, tokens. And that is going to be line dot split on space. Now we can do a match, because I'm using Python, I think it's 3.10 where that gets added, on tokens sub-0. We could say case rect. So in the case where it's rect, which in my example here is just the first one, what are we going to do? We're going to process that. So we need to get the term, we got the word rect already, that's good. We need to get these two numbers. So we'll say tokens sub1 dot split on the term x. And that should be fine. And we can call that like A and B, like, so because we know we're only going to get, this is not robust code, but if I assume every time I have rect, I'm going to have this exact format, I'll split once and get A and B. And then we can do self.insts.append. We'll just make a tuple here that says rect int A. In fact, you know what we can do? I think we, let's just do this. We'll do int A, comma, int B. And I think that looks, we're missing one. There we go. Okay, so now we can do case. In fact, we'll just do case everything else. So if it's not rect, it's going to be rotate, right? And we can even do an assert right here. Tokens sub-0 equals rotate. And that way, if we ever get something that's not rotate, we want to fail because we expect everything to be rect rotate. So now we can say A equals, and in both these cases, the first number where it's going to be the 0, 1, 2 tokens 2, skipping the first bits. So we can do tokens 2, and then we want to start from the second character on, and we want to take an int of that. And B, it's our second number, is going to be just tokens int of tokens 4. So we're good there. And now we can say self.inst.append. And in this case, we'll do tokens 1 to get whether it's a column or a row. And then we can do A, B, and we've already done the ints, so we don't have to do that again. And I feel like we're in pretty good shape here. Let's see, I can probably get rid of you. What happens if I run F5 now? And when I run F5, I'm actually running PyTest now. I have a video that I think I put out yesterday where I showed how to configure my launch.json so that I can set whether I'm in the current file or whether I want to run PyTest. And so I'm hitting F5 to run PyTest, and I'm running and I'm passing. So we are parsing the things as we expected. So let's think about the next thing we need to do. Not only do I want to parse, I also need my object to have a screen because we're going to need to track these pixels on the screen. So we will do def test screen init example 1, although it doesn't really matter, I don't think. We can say screen equals aoc.screen example 1, and I could have added it to the test parse honestly, but I'm just kind of give myself another test to keep it clean here. Test screen dot, and what do I want to call this? I guess I'll call it screen dot screen. What do I want to do? Assert len maybe of the screen dot screen. In this case, is going to be for my example, I'm going to have 3 rows. So I'm going to have 3, and I can do an assert len screen dot screen sub-0. So the length of the first one is going to be 7. So I should have 7 columns. And now we can hit F5 and run this, and we should fail. Screen object has no attribute screen. Perfect. Let's go back here. We can come down here and we'll do it here. Self.screen equals. And now, so what do we want our screen to be? We could just do arrays, but actually there's a thing called a deque. So we can do from collections import deque. And what's cool about deque is it actually has a rotate feature built in. And if we have a rotate feature, we can just use that for some of the twists that we're going to be doing ahead. So what we want to do is we'll have a list of deques. So each row will be a deque, and then we'll have a list of those. So what we're going to do is we're going to make a deque, and that deque is going to be 0 for underscore in, and this is going to be the number of C. So we need columns. So we really, because we have 7 columns in the example, but I think we said 50 in the regular one, we're going to need to go ahead and define that. So let's come here and we can say calls equals, and maybe we'll make the default 50 rows equals, and the default will be, they say 6, I believe. Okay, so now we can go down here and we can say for doesn't matter. So we would want to get columns. We want that many columns. So now we're going to make a deque that's that many columns, and we're going to do that rows times. So for underscore in, we need range rows, and we need to make this a range 2. So like that. So now when we do self.screen should be a 50 by 6 array we can track. And the internal stuff should be deques. So now if we come up here, we should probably go ahead and say, if we run this right now, my hope would be we're going to get 50 does not equal, yeah, so 6 does not equal 3. Do we get 50 does not equal? I guess maybe we died right there. So now we can do here is we can say example 1, we can say calls equals 7, rows equals 3. Run that again. And we did not. So let's see. Of course, because we said calls equals 7, not 6. And now we pass. So now we're passing. We've initialized our screen. If we wanted, we could come down here and let's see, what's the best way to do it? We can come right here, maybe hit F5 and run this with a test. And now we're debugging. So we can do screen and see what exactly does it look like. And we can see we've got 3 deques, each all initialized with 0. So that's what we expect. We could add some stuff in here, like where we just pick kind of like a random assert screen sub 2 comma, not 2 comma, sub 2 comma 4 is equal to 0, just to make sure we're initializing to 0. And if we rerun that now, we can take this breakpoint out, run it ahead, and we fail. Screen object is not subscript. Oh, of course, screen.screen, and run that, and we pass. So we've got our screen now. It's looking like what we want. The next thing we need to do is start figuring out how to parse instructions. And so let's see. I guess we're in a kind of part 1 now. And to test part 1, we are going to, let's see, we don't need any of this. We will put in example 1. We're going to AOC.screen on puzzle on example 1. And we're going to call this screen. We're going to make a screen. We better make it the right size. Calls equals 7, rows equals 3. That's what our test input looks like. Now, what exactly do we want to test here? We're going to need to do something to run the instructions. So we'll call it like screen.run here. And then we're going to have to assert that screen.num, we'll call it pixels on equal to, and we need to find our example here. At the end here, we have 1, 2, 3, 4, 5, 6. We have 6. It's equal to 6. And that's all we're going to do in part 1. That's a lot, but we'll have to, that's a simple test, right? So we can come here and we can start to think about, okay, what does this look like? So we aren't going to need parse anymore. We aren't really going to need we're not going to have a part 1 function or part 2 function. Let's get rid of this. We're going to come down here and we're going to say screen equals screen puzzle input, like that. And then we can say solution 1 is equal to screen dot pixels on. We're going to need to do a screen dot run. And we'll, for now, because we don't know exactly what the challenge of part 2 is, we'll say none. And now we're looking like we're in good shape. We just need to write these run and pixels on thing. Okay. Pixels on is going to be pretty easy. We can do that first. Def pixels on self returns an int. And what are we going to do? So we're going to loop over, we're going to take each row, and we're going to count up the numbers. And we're storing zeros, and I'm going to say ones when they turn on, so I'll make it really easy to count. So we can say, let's see, we'll say row for row in self.screen. Now we've got the row, and for each row here, what we're going to do is we're going to say v, like value for value in row, and then we can just take a nice sum here and a sum of that, and we can return that, and I think we're good. We come back here and we try to run this now. We can even take screen, well, we'll do, we'll define stream.run and just make it a pass for now. Def run self none pass. So now we actually should be able to run this and see our test, and we are not doing any of the actual instructions, so we return 0 pixels on. We should return 6. So it's looking like what we want it to look like. Let's talk about run now. So what we're going to do is we're going to loop over all the instructions. So before inst in insts, and that's going to be self.inst, like that. So for each instruction, what are we going to do? We're going to match on oh, actually, we can do it even cooler. We can say inst a, b, because each of them have 2 numbers in an instruction. Now we can do a match on inst, I think, case of Rect. And what are we going to do? We're going to call, let's just call self.rect a comma b. I think that's enough. We can case column self.call self.rotate call a comma b, and case row self.rotate row a comma b. Case underscore, we should not hit anything else, so we will raise. Throw an error. So what we've now done is we've said we basically are just going to loop over all our instructions, and for each of them, we're going to do the thing we do. So we need to define those things. So we'll come back here and we will def rect self a, and let's see, let's be a little careful what we're getting here. A is going to be in our rectangle, A is going to be our, this is the number of columns, calls rows, like that. And so what are we going to do here is we're going to do a for row in, just make sure we get this, like rotate, we get my head right here. For row in self.screen sub row, like that, sub rows. So if we have 2 rows, we're going to get first and the 0 and 1, and then if that's 2, so I think that's right. And then we can do for call in self.screen, oh no, in row, and then we want to do the same thing, so this time up to calls. Call equals 1. I think this will work because of the way arrays, lists, and queues are passed by reference, like it passes a pointer to the object. Updating the value just like this should be fine, but we will test that. Let's see. If we come down here, we can do def rotate call, and this time we're going to call it x comma by. We'll just call pass for the moment because I just want to test this. Def rotate row y by pass. So now if we do this, we should be able to run our test and see row index must be a sequence, must be an integer, not a slice. Oh, interesting. What is rows? Um, let's see. Let's pause. Let's break right here and see what we're doing. Something's kind of wonky. So we are about to say A is 3, B is 2. That looks fine. So if we go into that, so self dot screen looks good. Okay, so rows, that looks fine. That gives me the first 2 rows. We take the first one of those and we do that in calls. We do that. That's where we're failing. So what is calls? 3. Doesn't like that. We might have to just, for sake of, we can't slice into a deck maybe. Let's do it differently here. We're gonna do for row in range rows. Or call, let's make it, I don't know why, but I like it better as R. For C in range calls. And then we can say self.screen.r.c is equal to 1. Let's try that, see how it works. Turn off that breakpoint, and we get screen rotate call takes 2 positional arguments with 3 were given. Oh, we need self, and we run again, and we pass. Now that's interesting. We pass this time because when we created those 6 pixels in the first one, they just stay on. Even they rotate around. There's no more rectangles coming on, so that actually works. We don't actually effectively test our rotate column, rotate rows, but that's why passing actually just makes it work. But it tells us this is working well. Let's start to think about our rotate column, rotate row. We do row first because row is really easy. All I need to do is do self.screen sub y, and that'll give me the deck of that row. And then I can use the rotate function of the deck to rotate it, and I'm done. That's literally all of our that's all our thing is right now. Rotate columns can be a little more complicated because I don't have a way to grab the columns. What I'm going to actually do is go and create myself a new deck that is the column. And so we'll do it like this. We'll say call is equal to deck. And now we're going to say, we're going to pass an array, a vector, where we say row sub x for row in self.screen. So we're going to go over each row. And for each row, we're going to get the x item, and we're going to create a column that is a queue. Now we can call that rotate by. And now we've got what the rotated column should look like. So now we just need to loop back over and put it back. And so we can do for, let's see, what I'm going to do here is I'm going to zip together self.screen. So that'll give me let's say in this case, 3 rows. And then I can say the column. And so what it's going to do is it's going to give me the first item in the column and the whole row paired together. And so what that will look like, it'll be for row comma new val in that. And so now I can just say row sub x, because we're still putting it in the x place, is equal to new val. And we're done. Let's F5 this. Looking good. We're still passing, so we're all happy. We haven't guaranteed that our rotations are working, but we at least are passing part 1. So we can probably, in fact, we can see if we can solve part 1 at this point. Let's see. I'm going to change this to current file. I'm going to go to part day 8 and F5 this, and I get 116, and I believe that was my answer. 116. So we are successfully doing the rotations right, because if we weren't, it wouldn't work out. Okay, part 2. This is actually code. So we notice that it's capable of drawing capitalized letters in the font it uses. Each letter is 5 pixels and 6 tall. What is it trying to display? Let's go down here. We just need to make a print function basically. So we can come down here and we can say def. We'll call it like to string self and string. And I want to not just print it here, but actually return the strings. That makes it easier for me to test. And so what is that string going to look like? Well, what we want to do is we want to say, we'll say s is equal to, that is empty thing. So then we can say for row in self.screen for val in row, if val equals 0, s plus equals, we'll say dot, else s plus equals hash mark. That's what they did. And then after each row, we want to do s plus equals new line. And we did not pretend we didn't do any of this. We're supposed to make tests. Let's see. Go around here and grab this right here. We need to make our tests. Don't need any of this. Example 1. And we will do the same kind of thing here. We'll do screen. We'll call this screen. We'll make this example 1. We will do screen.run. And then we will assert that part that, let's see. We will assert that screen.toString is equal to, put this in. We can put a new line here, a new line here. We don't want a trailing new line. We'll end it there. So that is our test. Let's run it. It shouldn't pass yet. Okay. Oh, we're running current file. Test. We're failing. Good. So we have assert string to string. So we have a, we aren't even testing. So we should call the function and F5 it. And we're failing none. We're returning none right now. Perfect. Okay. So we come down here. Now we build this out and we return s. And let's see if we got it without error on the first time. Not quite. Okay. So we have an assertion error that we're not getting the new line added. Oh, we made way too big a thing. Example 1, calls equals 7, rows equals 3. Let's try that again. We're getting closer here. So we literally are the same, except we aren't adding a new line to the end. So let's see, dot strip. Let's make it r strip to take care of any new lines on the end. We'll test again, and we pass. So now we can come down here and we can say screen dot toString, and let's go ahead and add a new line in front of that so that prints okay. Change this to current file, run this, and we have a UPOJFLBCEZ. And I believe that matches UPOJFLBCE. Cool. This was a really fun challenge. I struggled with it mightily the first time, and I think it took about 10 minutes longer to solve it. So the benefits of having done it a second time. Yeah, thanks for hanging out. Okay, quick head fake here. I was playing with this a little bit after quitting. And basically what I did was I took my toString function and I added a fancy variable here that adds some extra stuff. And instead of using dots and hash marks, is using some other characters here. And then I gave myself an animate function, which is going to clear the terminal. And then it's going to print the fancy version and it's going to sleep for a short time. And if I put the animate into the run function, I get kind of a cool result. I just thought it'd be worth showing off real quick. So I'll do Python day 8. And if I run this, you can actually watch the pixels move into place and you can see them shift around. And after a minute or two, you're going to see they settle in and form the result. So I don't know. I thought that was kind of cool. Just thought I would add that in there. The code will be in the repo. You can check that out. I'm not going to go into more detail. And I didn't write tests for the fancy version. So You'll have to forgive me on that one. Anyway, thanks for hanging out with me today, and I'll talk to you next time. Bye.